Hey, good morning. Mrs. Spatola here. Here are the answers from our last homework assignment, so take a look here. We are applying the distributive property in word problem. The answer to number 6 was $16. Okay, $16 spent on pencil. Here is the setup. And I know right away you would probably want to say, well, it's really 2 times 5 plus 3 is 8, 2 times 8. When you're applying the distributive property, you cannot do that. Again, it's all about the directions and following the directions. Number 7 was a little trickier. There really should have been a number here for the exhibit, okay, for the price of a student, but as long as you set it up like this, that's what matters at this point. And if you applied the distributive property like this as well, you're good to go. The next two order of operation problems are as follows. We have an answer of 4 here, and then we have an answer of 34. And last but not least, we have the 2 challenge problems. The next one, the answer was 0, and then the last one, the answer was 20. Hope you did well, and let's take a look because today we're going to be translating expressions. In today's lesson, Unit 3, Lesson 7, we're going to be translating expressions. Now, the objective is, how do you translate expressions? Well, before we even talk about that, what does it mean to translate? Think about that. You may have heard that in different areas other than math. Translate. What's the first thing that comes to your mind when you hear the word translate? Well, for me, I think of translate, I think of maybe changing from one language to another. Often we have translators that will translate a foreign language to English so that we can understand it better. Well, just like you would translate a language, math, believe it or not, is a language also. And sometimes we'll have the written form translated or changed to the standard form. So that's exactly what it means. So to translate means to change. So let's write that down. So I hope you copy down the definition for translate. It means to change from one form to another. In math terms, it means to change from word form to standard form or standard form to word form. If we take a look over to our info box over on the right, we notice that there's this thing here called algebraic expressions. There is a lot of vocabulary terms, boys and girls, in this unit and specifically in this lesson. So let's take a look at some of these definitions. The first thing we see this expression here. Remember, an expression can be numerical or algebraic, and basically all it means is that it has numbers and an operation sign. If it's algebraic, it has this thing called a variable. Let's look at some of the terminology. First of all, we have this thing called a coefficient. A coefficient is a number that's right next to a letter. That letter is called a variable. And then we have a number all by itself with no other letters or anything around it. That's actually called a constant. And those two items put together are called terms. We will be spending a lot more time in a future unit on that, but it's important to understand the vocabulary because when you see it, you're going to need to know what it means. So what exactly is an expression? An expression is expressions are mathematical phrases, kind of like sentences without the period. Don't tell your ELA teacher that. A numerical expression, think about it. Numerical represents an expression with numbers only. We think numerical number. And if we take a look at the terms here, it says numbers and operation signs only, all of your order of operation problems. So all of the order of operation problems that we have been solving so far are called numerical expressions. Remember in class, we've always said there are no equal signs. There are no equal signs because it is an expression. An equation, something that we look at later, has the equal signs. Now let's take a look over here. We have something called algebraic expressions. Well, what's an algebraic expression? Well, algebraic expressions are basically the same thing as numericals, except it has something called a variable. It has letters, and one of the keys for algebraic, when we see algebraic, we think alphabet, right? Algebraic, alphabet. And that's where our letters come in because variables are letters that we use. Very similar to numerical, except it also has a letter or a variable. Now let's take a look at some of the vocabulary terminology. A variable is a quantity that can change, often represented by a letter. So, for example, in the following expression, 60 minus s plus 7, the variable would be the s. It's a letter. Next, we have the term coefficient. A coefficient is the number that is multiplied by a variable, and it is also the number next to the variable, next to letter or variable. Okay, get used to that. And when we're talking in class about letters, we want to start using the word, we're talking mathematics, we're going to use the word variable. Example, 4x plus 8, the variable is x and the coefficient is 4. Here's a hint. When translating algebraic expressions using variables, do not use the multiplication sign. If you notice in the example above, it shows 4x plus 8. Notice there is no extra multiplication symbol. Let's look at the example now below. The example below says 4 times x is written as 4f. We do not use the multiplication symbol because it looks like a variable. We write 4f when translating 4 times f. This is going to be part of your homework tonight. When the 4 is next to the f, it means multiplication. Next, let's take a look, and we're going to identify our new vocabulary terms, the variable and the coefficient in each expression below. Remember, an expression does not have an equal sign. Number 1, 9 minus 8n. The variable. So the variable is going to be your letter. So if we look at number 1, the letter is going to be n. The coefficient is the number that is next to the letter, which would be 8. You might be thinking, well, what about the 9? The 9 is something called a constant. We saw that at the very top of the page. A constant is just a plain old number. Let's look at number 2. 3k plus 5. What is the variable? The variable would be the letter k. When we see variable, we think of letters. So that would be k. What is the coefficient? What is the number next to the letter? That would be 3. The constant in this case would be 5, if you'd like to add that. We can actually go back to number 1. That constant was 9. Number 2, the constant was 5. Just a number by itself. Number 3, 22 minus 4p plus 6r. In this case now, we have more than one variable. I see a letter here and a letter here. So the variables for number 3 would be p and r. What are the coefficients? The coefficients, remember, are the numbers that are next to the letter. The coefficient in this case would be the 4, and for the other one, the 6. Is there a constant in that expression? Absolutely. That constant would be the number 22. Nice job. Let's go on to the next page. When we translate algebraic expressions, it means to change from word form to standard form. We use key words to help write the expression, And sometimes there is just one operation. Other times there are more than one operation. Today we're going to hopefully focus on just one operation at a time. Here are some examples. Take a look. Word phrase, this is the column for word phrases. This is the operation. So when you're reading these, you want to think about the operation. And then the algebraic expression, that would be your number phrase or letter phrase with a combination of numbers and letters. First example, 5 minutes more than the number X. Think about that. More than. What operation is that? It's addition. So what would that look like? It would be X plus 5. Okay? Next one. 10 erasers decreased by, key words there, decreased by a number N. What operation does that sound like to you? That would be subtraction. And that would look like 10 minus N. 10 erasers decreased by a number N, 10 minus N. The algebraic expression, this column here, is going to be your translation column. Next one, 6 times A with W times. So obviously we know it's multiplication, but keep in mind, we looked at that little hint earlier. Here is the translation for the multiplication, 6W. Notice it's not 6.W, and notice it's not 6XW. It's just the number next to the variable. That's super important. Next one, we have N nectarines, that's a fruit by the way, divided by 3. That's division. One way you could write it is N divided by 3, or if you recall from the beginning of the school year, we've been saying that fractions mean division. You could actually write it as N over 3, which actually means N divided by 3. In 7th grade, this way, the second way, is going to be the way that you're going to be looking at algebraic expressions for division. It will be written as a fraction. If you can get into that habit at the beginning, that would be a really good step so that in 7th grade, you're going to be good to go. Now let's look at another one. The last expression, example, is multi-step. It says 8 more than 4 times an amount X. That's multiplication and division. So that's 2 things. And that would look like 4X plus 8. All right. There's also a little trick in here. When you see the words more than, more rules here, that's what we call a switch word. The word more than is a switch word. It means to switch the order of the number or variable after it, switch the order and turn it around. So 8 more than 4 times an amount X. Well, I know that 4 times an amount X is 4X. I know that 8 looks like this. And more than means plus. But notice my final answer is 4X plus 8. That's because the words more than are switch words. Keywords review. Look back at keywords in the beginning of the book and place some of them in the keyword chart below. Those keywords can be found on page 7. So what you would want to do is look at the keywords and plug some of them in. Be sure to box up keywords to help you translate. I will actually include a copy of page 7 on the next page, so if you need to flip back and forth, that will help. N. Here are the keywords from page 7 in your workbook. If you'd like to use some of these keywords, you will definitely see a lot of these in the upcoming lessons. On this page, we're going to write the algebraic expression. We're going to look at some examples. In this column here, we're going to look at the actual word phrases. And on this side, we're going to look at the algebraic expression that would represent the actual word phrases. So let's take a look at this first section in here. Ready? 9 more than a number. Well, remember, I mentioned earlier that when you see the word more than or less than, that's going to be what we call a switch word. So that switches the order. Right away, you would look at 9 more than a number. So you would think 9 plus a number. We can call it n or x or whatever. But when you see the more than or less than, you switch the order. All of these that are in this section here represent the same algebraic expression. The sum of 9 and a number plus 9, a number increased by 9, and the total of x and 9. Well, when I look at this one here, do me a favor, just cross this one out because this one really doesn't apply here. That would look like n plus 9, or in this case, x plus 9. We see that the operation is addition, and that's how it would look. Let's go on to the subtraction section. In this section here, I noticed a lot of subtraction words. 4 subtracted from a number minus 4. 4 less than a number decreased by 4. The difference of h and 4. One other thing that I want to bring to your attention too, there's a lot of rules in math, boys and girls, so sometimes we address them as they come along. When you have this here, 4 subtracted from a number, that's also a switch. Okay, so here's subtracted from and then less than. So all of these would be represented by what? N minus 4. Or in this case, for the last one, h minus 4. You're looking for your keywords. Your keywords will tell you the operation. Let's go down and take a look at the remaining 2 sections. In this section, again, word phrases, here's the algebraic expression. 6 multiplied by g, 6 times a number. The product, remember a product is the answer to a multiplication problem, the product of g and 6. In a case like this, be really careful because this one is tricky. The number always comes before the variable. That's another rule we're throwing in there. Lots of rules we're throwing in here. That would look like what? 6g. Next section, division. Let's look at the division section. A number divided by 5. The quotient. What's a quotient? A quotient is a division problem. The quotient of t and 5. Divide a number by 5. It's saying a number. When it says a number, you're going to put in a variable. And a lot of times people just use, like I said, they use the variable x all the time, or we can just use n all the time to represent number. So in this section here, it's division. So what would that look like? N divided by 5. That would look like this. N divided by 5. But the 7th grade way to represent it would be as a fraction, and if you said that first, that's pretty awesome, would be n divided by 5. Okay, let's do some practice. In this section, we're going to write each phrase as an algebraic expression. Actually, this is what your homework's going to look like tonight. All of this hard work gets us to this point here, which actually becomes a lot of fun. We're going to be translating. Number 1, it says 7 less m. Think of the keyword. Your keyword here is less. Okay, your keyword is less, so it's 7 minus m. Number 2, the quotient. So if it's quotient, quotient tells me that I'm going to be doing what operation? Division. So the quotient of 3 and y would look like this. 3 divided by y, or the 7th grade way to do it, 3 divided by y. Number 3, the total of 5 and c. Total tells me most of the time, not every single time, but pretty much 9 times out of 10, this is going to be addition. So the total of 5 and c, that would be 5 plus c. Number 4, the difference of 6 and r. The difference. Difference is a subtraction word. So the difference of 6 and r would be 6 minus r. Number 5. Again, division. N divided by 2. N divided by 2. And the 7th grade way, n divided by 2. Try this one. This is a tricky one. Pause the video and try this one. The product of k and 9. Pause the video and try it. Okay, this one would be 9k. If you got 9k for that one, you did an awesome job. So here is tonight's homework. You're going to focus on the next page and you're going to complete the rest of the page. Numbers 7, 8, 9, and 10, you're going to translate from word form to standard form. You're going to write the expression, and then sometimes you're going to have to write the expression in words from the standard form, and you're going to practice that translating from algebra to word forms. Give 2 ways to write each algebraic expression in words. These are just some examples you can look at. And tonight you're just going to translate from standard form to word form. Just try those couple of problems. Have a great day, everyone.